In this video, we are going to discuss about the derivative of trigonometric functions or functions involving trigonometric functions. So, the very first derivative of this class is derivative of sin x, which is cosine x, and derivative of cosine x, which is minus sin x. Now, using this derivative, we are going to find the derivative of tan x, which can be written as sin x over cosine x. Now we'll apply the Quotient rule and find the derivative of tan x. So by Quotient rule we have cosine square x, cosine x, derivative of sin x minus sin x, derivative of cosine x, which is cosine square x, and derivative of sin x is cosine, and cosine square x minus sin x, but derivative of cosine x is minus sin x, so it will become plus sin square x. So cosine square x plus sin square x is 1, so it is 1 over cosine square x, which is secant square x. So therefore we have d dx tan x is secant square x. Now we will have our fourth rule, derivative of cotan x. So it's almost similar to the tan x. Here we will write it, derivative of cotan x is equal derivative cosine x over sin x, and we will proceed the same and we will get the derivative of the cotan x. So applying the quotient rule, we will have sin square x sin x, derivative of cosine x minus cosine x, derivative of sin x, and then which further gives as sin square x minus sin square x minus cosine square x, so which is equal minus 1 over sin square x equivalent to minus cosecant square x. So therefore finally we have our fourth rule, derivative of cotan x is minus cosecant square x. Now the fifth rule is derivative of secant x. Cosecant can be written as d dx of 1 over cosine x. Now we apply again the quotient rule, and we will have cosine square x cosine x, derivative of 1, which will be 0, minus 1 multiply derivative of cosine x. So derivative of cosine x is minus sin x, so minus minus plus, so we have finally now sin x over cosine square x, which finally can be written as sin x over cosine x and 1 over cosine x, which is nothing but tan x multiply secant x. So we have our fifth rule as d dx secant x is equal to tan x multiply secant x. The sixth rule is about the derivative of cosecant x. So now again the cosecant x can be written as 1 over sin x. Using the quotient rule, we can write it sin square x, sin x derivative of 1 minus 1 derivative of sin x. So derivative of 1 will be 0 and derivative of sin x will be cosine x. So you have minus cosine x over sin square x, which can further be written as minus cosine over sine 1 over sine, which is nothing but minus cotan x cosecant x. So our last rule is derivative of cosecant is minus cotan x and secant x. Now using this 6 rules of the derivative of trigonometric functions along with other basic derivative rules, we are going to solve many numerical problems. Our first example is find y dash if y equal x sin x plus tan x. So derivative of tan x can be seen from the list, and x sin x we will see how we can solve it. So y dash can be written as d dx x sin x plus tan x. Now apply the addition rule, f plus g is equal f dash plus g dash. we have derivative of x sin x and derivative of tan x. Now to have the derivative of x sin x, we'll use the product rule, which is f g prime plus g f prime. In this case, x derivative of sin x plus sin x derivative of x plus derivative of tan x from the rule is secant square x. Now derivative of sin x is cosine x and derivative x is 1, which gives finally x cosine x plus sin x plus secant square. Our next example is find dy dx for y equal x square secant x plus cosine square x. Applying the addition rule, we have dy dx is equal to dx x square secant x plus ddx cosine square. We don't know any rule for the derivative of cosine square x, so we write cosine square x is equal cosine x multiply cosine x and use the product rule. So therefore both the derivative will solve it by using the product rule. So we have x square ddx secant x plus secant x derivative of x square. So for the derivative of cosine square x, we can use the product rule. It can write as cosine x derivative of cosine x plus cosine x derivative of cosine x. From the table we have derivative of secant x is tan x secant x, and derivative of x square is 2x, and derivative of cosine x is minus sin x, which give me the derivative as x square tan x secant x plus 2x secant x plus 2 cosine x minus sin x. Then after the simplification, we have the final answer as follows. Now 2 sin x cosine x is sin 2x. Using this, we can write our final answer is x square tan x secant x plus 2x secant x minus sin 2x. Our next problem is find dp dq if p is equal cotan q 1 plus cotan q. So to find this derivative, we will use the quotient rule, and by quotient rule, we have here dp dq is equal 1 plus cotan q whole square, then 1 plus cotan q derivative of cotan q minus cotan q derivative of 1 plus cotan q. So from the table we have cotan derivative of cotan is minus cosecant square. So we can write that as denominator 1 plus cotan q whole square and 1 plus cotan q cosecant square q minus cotan q 0 plus cosecant q. Now simplify them. So we have here minus cosecant q minus cotan q cosecant square q plus cotan q cosecant square q 1 plus cotan q whole square. Then cotan q cosecant square is cancel out. So we have the final answer as minus cosecant square q over 1 plus cotan q whole square. Our next example is to find the derivative y equal to tan square x minus secant square x. Now we don't have any rule of tan square x and secant square x. So using product rule, we will find the rule for tan square x and secant square x. So we can write tan square x as d dx tan x multiply tan x, which is 2 tan x derivative of tan x. If we use the product rule, then we have the derivative of tan x is secant square x, so therefore we get it 2 tan x multiply secant square x. Same way, derivative of secant square x will be 2 secant x derivative of secant x. Now derivative of secant x is secant x tan x, so we will get it 2 secant square x tan x. So this give us dy dx equal 2 d dx tan square x minus d dx secant square x, which we write the derivative here, and after simplification we get it. The answer is 4 tan x secant square x minus 2 tan x secant square x, which is nothing but 2 tan x secant square x. Now this problem can also be solved in another way, by recalling the identities. Tan square x minus secant square x is equal 1. So by which we can write y is equal tan square x plus tan square x minus secant square x, which is equal tan square x plus 1. So therefore, if we know only the derivative of tan square x, we can write the final answer. So which is equal d dx tan square x plus d dx 1. So derivative of 1 will be 0, and tan square x we already calculated. So 2 tan x secant square x, and this is the final answer. Our next example is y equal to the power x multiply with tan x, which we can write dy dx is equal to dx to the power tan x. Then we will apply the product rule, which is written in the right hand side, and we have e to the power x ddx tan x ddx e to the power x. So derivative of tan x is secant square x, and derivative of e to the power x is e to the power x. So we have the answer here, e to the power x secant square x plus e to the power x tan x, and we rewrite the answer as e to the power x secant square x plus tan x. Our next problem here, the find y double prime if y equal minus cosecant x. So first find the first derivative, y dash is equal minus d dx cosecant x. So we know that cosecant x is minus cotan x cosecant x, which after simplification we have plus cotan x multiply with cosecant x. Now we take the second order derivative, and in the second order derivative we have used the product rule on cotan x multiply with cosecant x. So which we can write it as cotan x multiply with derivative of cosecant x plus cosecant x multiply with the derivative of cotan x. Now derivative of cosecant x is minus cotan x cosecant x, which gives us minus cotan square x cosecant x minus cosecant x, and derivative of cotan x is cosecant square, so togetherly it is minus cosecant to the power 3 x. On further simplification, we have the answer is minus cosecant x multiply with cotan square x plus cosecant square x.